Hello my lovely juniors, this is Ashok and welcome to my YouTube channel. In the today's video, that is part 6, we are learning about the working principles of VFD. It means on what basis this variable frequency drives will work. Okay. First one, what is mean by working principle? You should know this. So it is a rule that is adequate to permit the work to be done. Means any rule how it will make any device run. Okay, otherwise it is a working rule or a type of regulation or a rule, a principle or a condition that customarily governs the behavior. How one device should work, it will tell. That is called as the working principle. Second one, basic understandings of VFD. First one, we should learn all these. If you want to know how VFD will work, we should know all these: DC current, AC current, frequency, and single phase and three phase electricity. First one, difference between the AC and DC. So we have always listening about this, right? What is mean by DC, what is mean by AC. So we will see it now. First one, so this is the DC current, this is the AC current. Okay, so first difference is the direction we are checking. DC current is the one-way direction. It will move always in one direction, but the AC current, it will move in the both direction. Second one, distance. So DC current, it will travel only short distance, but the AC current can travel up to long distance because this is a more powerful. Third one, frequency ratio. So this will be around the 0 hertz always DC current, because there will be no variation in the current. If you see in the AC current, have you seen this graph? Here we can see different colors I have mentioned here, means different territories and different countries will use the different frequencies in their country. Our India's here we have blue. All these almost Asia we are using about the 220 to 240 volts. If you see this northern and some little European, Australian countries and European countries, they are using only 100 to 120 volt. Okay, this is the frequency ratio. Magnitude, DC current magnitude will be constant and AC current magnitude will be vary with the time. And then power source, DC current where we can see, so like battery or cell inverter in our home, wherever it is there, we can see the DC current. AC current we can check only in the generator. And then the waveform, DC current waveform will be straight wave and AC current will be the sine wave. This is called as the sine wave, alternating current. This is the direct current. So now we will see what is mean by the frequency. If you see, this is a mall, right? In the mall, so many people are coming and going. So you might have heard this thing. So what is the frequency in your area? It means for every second how many people coming, how many people going. So that is called as the frequency. That is why formula of the frequency is F equal to 1 by T, that is inversely proportional. Same like this, when we are increasing the frequency of a device per second, how much rotation it should do. It means how we are calculating here, 1 second how many people are coming, how many people are going. That is a frequency. So it is a simple meaning. I think you have understood this. If you don't have, if you still not get what is mean by frequency, you can put in the comment. Frequency is the number of occurrences of a repeating event per unit of time. F equal to 1 by T. Here F is the frequency and T is the time. As I told, frequency is the inversely proportional to the time. So this is see, frequency means what? Here we have plus wave, here is the negative wave, one fully sine wave. This is called as the frequency. Means in 1 second how many waves will generate. That is called as the frequency. That's it, very simple. Then we will see difference between the single phase and three phase. You might have seen in home you will be having the small wires, right? So this is called as the single phase. But from where the current coming to your home, it will be like this. RYB normally will use red, violet and blue, but here they have used yellow, green and blue. That is a different thing. So what will be the difference between these two, single phase and three phase? We will see. First one, okay, I think I have missed my slides. No need to worry. In the single phase we are using only two wires, one is the neutral and one is the phase and another one is the earth. But here it is not like that, there will be no ground here. We are using all are same power, 230 volt, 230 volt, 230 volt. In all three wires it will be power is coming. So that is the difference between the single phase and three phase. Here it will be 230 volt and this is the total is the 415 volt. Okay, that is the main difference. And the working principles of VFD. So if you see, some people are riding bike, right? Normally you also ride the bike. While riding the bike, how exactly it will work? You will increase the speed, right? You will change the gear and you will increase the speed. How it will be 10, 20, 30, 40, 50, 60 up to 90 we will go. It means however you are increasing the speed of the bike, that much RPM it will rotate, right? So if you are going in the 10 speed, this wheel, whatever you are seeing, it will rotate very slowly. But as you increase the speed, the rotation of the wheel increases, right? So that is called as the RPM, rotation per second, rotation per minute. As you increases, the speed of the wheel will increase. So that is called as the speed, how it will work. Okay, same application is there for the motor in the industry. So here we have motors, right? I want to increase the RPM, means I want to increase the export of the some oil or any material which is connected to this particular motor. So I want to increase. What I will do, when I will increase the frequency, it will have the more rotation. When I will decrease the frequency, it will have the low rotation. That's it. So working principle of VFD, this is, say, here we have one PLC, drive, motor, and here I have some level, water level. Okay, so this PLC is connected to the drive. So I am giving some set point like 50 RPM or 100 RPM. What it will do, it will calculate how much current it should give to the motor, and this drive will give that particular current to the motor. Based on that, this motor will operate, and whatever the level I have here, so the force of the water will come into that particular force. It means the PLC sending signal to the VFD and VFD calculating. For example, the maximum RPM, rotation per minute, we have 0 to 100. Okay, what I will do, I will give 50 RPM. It means for example, it is giving from 4 to 20 milliamps, it is sending to motor. So what it will do, okay, we will check it as a 0 to 10 milliamps. Okay, what it will do, when I set the RPM as 50 and my maximum range is 0 to 100, what it will do, it will send 5 amps. It means the motor will rotate in the half of the speed. No, I want full RPM, 100 RPM, means what it will do, it will give all the 10 amps to this motor, means this motor will rotate with the high speed and water will fill very fast. So this is the very simple working principles of VFD. Before writing, if they are asking for 5 marks, 10 marks, write all the things what I have told before. What is mean by DC current, AC current, all these four things you have to explain, and then you can conclude this one. And after that, you have to write this diagram. So I will explain now in detail. In rectifier, DC bus filter, inverter, control unit, what all it will do, now we will see. So these are the main parts of the our block diagram, inverter or this VFD block diagram. So first we will see what is mean by rectifier. Okay, it is an electronic device which converts the AC current into DC current by allowing the current to flow in a single direction. See, here we have rectifier, right? So here what it will do, first 3-phase current we are giving, this rectifier converts this 3-phase AC current into the DC current. So here we have DC bus filter, right? So that is the meaning. Okay, then what we will do, rectifier working principle. So here we can see we have diodes here, right? Diodes allow the current flow in only one direction. Okay, here we have diodes, and then the current flow is from the anode to cathode. It means plus to minus. So this is what about the rectifier. So output of rectifier, what it will come, output of rectifier will be the DC current. As you see here, this is the rectifier, 3-phase current is coming. After that, this rectifier converts the 3-phase current into DC current. It means that sine wave, it will come like this, right? It will, I'll show you, pen will take. So what it will do, when the current comes here, it will be like this, sine wave. But when it is entering here, so this sine wave convert like this, means it will remove all the negative waves. This is the positive wave, this is the negative wave, right? So what it will do, it will remove all these negative waves, and it will keep only the positive waves. Okay, this is the DC current which it converts. And DC bus filter, what it has to do, we will see now. So this is the output of the rectifier, I told na. So like this is there, AC wave, sine wave. So rectifier converts this one into this, like this. It is removing this negative part. That is the main working of the rectifier. You can write like this. Okay, then DC bus filter definition. So next we have here DC bus filter, right? So what this DC bus filter will do, we will see now. It is an electronic device which converts the pulsating DC to the pure DC. I told, right? So in the first part it is like this, correct? Then from this one rectifier, what it has done, like this. So this way it has given, but this is not correct because our DC wave is like this. It is a straight wave. So this bus filter, it converts this one, means see, this is the pulsating DC. It is not the pure DC. So what it will do, when the current enters this one, DC current enters this one, this will change this pulsating DC into the pure DC. So that is the main part of the DC filter. Filter means what? So it is filtering all this pulsating thing and making the straight wave. If you see here, we are using one capacitor and the resistor also. What is mean by capacitor? Capacitor used for the charging the current which is coming from here, and resistor, what it will do, it will resist the current, means I don't want the extra current which is coming here, I want the straight one, that one is entering here. Next one, so capacitor, what it will do in this one, it is used in the filter to store the DC charge coming from the inverter and then transfer the supply to the pure DC as the output. Okay, and the resistor, what it will do, it is used in the filter to reduce the noise in the charge or current and helps in the wave smoothing of the DC. I told na. So like this was there and it changed to like this. So this one resistor help us to remove the noise and converting into the pure DC. Next one, inverter definition. So what we have done, rectifier completed, DC bus filter we understood. What is the inverter? So now we got DC wave like this, sir. Now what is our next step? So what is the inverter? We will see. This is the inverter, is the same thing which we are having in the home. Now I will show you what the inverter will do. So now first we will see what is the inverter definition. It is a electronic device which converts the DC current into the AC current by allowing the current to flow in both directions. So I told na, in DC current it is only single direction, okay, but in AC it is the both direction. So what it will do, so DC wave means straight wave already we got in the bus filter. Then what it will do, now for AC current drive, so I want to run with the AC, that's why what it will do, then this AC, DC current, it will change to AC like this again. Okay, I will show you. So IGBT, this transistor, bipolar transistor we will use, insulated gate bipolar transistor. This is called as the transistor. Total 6 transistor we have in the inverter. What it will do, we will see. IGBT function, insulated gate bipolar transistor. The AC DC conversion mechanism switches power transistor as the IGBT and changes the on-off intervals to create the pulse wave width, different width, and then it combines them into a pseudo sine wave. This is called as the pulse width modulation. Sir, if simply you are reading like this, I am unable to understand how it means. Like, see, what is happening? So your wave is coming like this. Okay, this one. So when it is when the current it is coming, it was straight wave, right? So it means that it is the DC current. It is going like this, on off on off on off. So what it will do, when this particular current transferring through this IGBT, it will form a sine wave like this. See, it will convert this into this sine wave. You can see the dots here, right? It is connecting this dot. This is the main function of the IGBT. You can write it. It is changing the on off wave into the pseudo sine wave. Next one, revision. So we have run, right? Power supply is there. We have converter which is changing from AC to DC, and then inverter. This DC bus filter we have. See, here only they have given very neatly. This is the first step. And what happens, then it will remove all these negative in the second step, and third one in the pulse width modulation. What it will do, here it will come like this after input. See, this one, it is also a sine wave before, but it was only DC. It is coming like 0 1 0 1 0 1 0 1 0 1 like this. So what it will do, this thing it will convert into a sine wave. So this is the simple working principle of an VFD. You can, if they are giving for 2 marks, you can write little information. If they are giving 10 marks, you can write about all these, and I think this is very, very simple. In the next video, we are learning about the VFD with motor control panel. So when the VFD in with the motor control panel, what all things will be there, we will check. Okay, so till then, see you. Bye bye.